First thing from the section that we're going to talk about is something called a combination function. And then we're going to have four different types. So first what we're doing is we're given just two functions, f of x and g of x. And then we're going to define some other ones. So for example, if we write this, f plus g of x, this is just a short way of writing f of x plus g of x. If we write f minus g of x, this is just another way of writing f of x minus g of x. If we write fg like this, so just f times g of x, this is just a way of writing f of x, g of x. And then lastly, if we do f divided by g, again, this is just another way of writing f of x over g of x. So with this, let's just do a quick example. Say if we have two equations. We have f of x is equal to x squared over 1 plus x, and we have g of x is equal to 1 over x. So let's find a couple of these. Let's start with f times g of x. Okay, so this just means if we look up this chart, if we do f g of x, that means we do f of x times g of x. So let's write f of x down. And then we'll write g of x down. Okay, so but here this x on the bottom is going to cancel out with one of these x's on the top. So this is just going to be x over 1 plus x. So f g of x is just equal to that. How about let's do f plus g of x. Okay, so we're going to have x squared over 1 plus x plus 1 over x. Okay, so now we need to find a common denominator. Well, this one has a 1 plus x on the bottom, and this one has an x on the bottom. So our common denominator is going to be x times 1 plus x. So in this one over here, we have to put an x on the bottom of this one and an x on the top of this one. So when we do that, we're going to have x cubed x over 1 plus x. So again, all we did here is we took this one and we put an x on the top and an x on the bottom. If we put an x on the top, that's going to turn into x cubed. And if we put an x on the bottom, that's just going to be x times 1 plus x. Okay, now on the bottom of this one, we have to put a 1 plus x. And on the top of this one, we have to put a 1 plus x. So we'll have 1 plus x all over x, 1 plus x. So again, 1 plus x times 1, that's just 1 plus x. And 1 plus x times x, that's x times 1 plus x. So now we have our common denominator, so we can combine these together. So we're going to have x squared plus 1 plus x, sorry, x cubed plus 1 plus x, all over x times 1 plus x. Okay, and so let's just take care of the example for this one. So the next thing from this section, these are called composition functions. All right, so the symbol for this is, again, so we're given two equations, f of x and g of x. And then we're going to find a new equation, f circle g of x. And this isn't multiplication. This doesn't mean f times g of x. This is not the same thing as f g of x. So these are two separate things. If we have a little circle here, this is going to mean something else. So let's talk about just this piece. So if we have that f circle g of x, the definition of this is we're going to take f of x and we're plugging g of x inside of it. So again, just a quick example. Let's say if we have f of x is equal to, let's say 3x over 2 plus x, and then g of x is equal to 1 over x. And we want to find we'll find both, f composed of g of x and g composed of f of x. So first, just off to the side. So remember, in this situation, not f of x. Let's say like f of 0. We know that when we plug in, that means we're plugging in 0 for x. So this is going to be 3 times 0 all over 2 plus 0. So that's easy. You put in a number for x, all you do is plug in that number here and plug in that number here. But now we're plugging in this function, so let's do that over here. F of g of x. So just like before, if we're plugging in a 0, we plug a 0 in the top for this x and a 0 right here for this x. Now we're just going to plug a g of x in. So this is going to be 3 times g of x all over 2 plus g of x. All we're just doing here is, so we're plugging g of x inside of f, so we're replacing these x's with g of x's. And so this right here, let's write that. This is f. So f composed with g of x, this is the definition. We're going to plug g in, so the one on the right we're plugging into the left. So we're plugging g into f. Okay, so here's f, we're plugging g inside of it. So we're going to put a g here and a g here in place of the x's. So now we're going to replace the g of x's with this. 3, 1 over x, 2 plus 1 over x. Okay, so another part of this problem, let's also find the domain. So let's do this, and also we're going to find the domain. So when we're finding the domain of composite function or composition functions, so the first thing we have to do is just figure out the composition function. So say, for example, in this one, we're trying to find the domain of f composed with g of x. So we plug everything in, we get to this step, and then we replace the g of x with this. And in order to find the domain, we can't simplify. So to find the domain of f g of x, do not simplify. So this is really important. When we're finding the domain of this, we want to find the domain of this version. So we could simplify this, meaning like, we can, for example, get a common denominator down here. We'd have a fraction. Combine these two, we have a fraction. Then we'd have a fraction divided by a fraction, so we could simplify it even more and get to like a nicer answer. But if we find the domain of that, we're going to make a mistake. So we need to find the domain of the unsimplified version. So let's just find the domain of this piece. So just like before with the domain, there's two things, the fractions and then also the square roots. All right. So in this situation, there's no square roots, so just don't need to worry about that. But there are fractions, and there's fractions in several places. Well, this entire thing is a fraction. This top right here, 3, 1 over x, that's the top, and the bottom, 2 plus 1 over x. And then there's also fractions just on the top and the bottom, like there's a fraction right here, 1 over x, and there's a fraction down here, 1 over x. And just like before, so remember the bottoms of fractions can't be 0, so every one of the fractions we have, the bottom of those can't be 0. So for example, of this fraction, just 1 over x is the bottom of this fraction, so x can't be 0. Again down here, here's another fraction, it's the same thing, 1 over x, so the bottom of this fraction can't be 0 again, so x can't be 0. And if we think of this whole thing as a fraction, like here's the top, here's the bottom, this is the bottom part, 2 plus 1 over x. This also can't be 0. So we have these three things that can't be 0. These first two are the same, so technically we only need to write one of them. But now let's figure out when is this part going to be 0, the 2 plus 1 over x. So let's just work on that one. So on this one right here, we could subtract this 2 over. So we get 1 over x can't equal to 2, or minus 2. Then what we can, that's fine, just keep going like this. Then what we could do is let's multiply the x onto the other side. So 1 can't equal minus 2x. And now let's divide this 2 over to the left-hand side. Negative 1/2 can't equal x. Okay, so now we have these things. We have, just from these two, the x can't be 0. And then from this one, this bottom piece right here, 2 plus 1 over x, this is not allowed to be 0 because it's the bottom of a fraction. So if we solve for x in this situation, right here I'm just treating this not equals to sign as an equal sign. So we can still solve for x, just pretend this is an equal sign, and that's what all these steps are doing. But when we solve for x here, we get that minus 1/2 can't be x. Okay, so just like before, we're going to go into our number line. So here is minus 1/2. Here is 0, we put circles on them, and then everything else is okay. So our domain is going to be minus infinity up to minus 1/2, minus 1/2 to 0, and then 0 to infinity. Okay, so that just takes care of the domains part. But now let's keep going and simplify this. Let's put that next line down here. So if we simplify this top, 3 times 1 over x, that's just 3 over x. Now on the bottom, we can simplify 2 plus 1 over x by getting a common denominator. So right now this 2 has a 1 in the denominator, but we need to put an x here. So we need to put an x on the bottom and an x on the top. So we're going to have 2x over x plus 1 over x. So here we put the x on the bottom and then the x on the top. We still have this 1 over x. So now we have the same denominator, so we can combine them. So we're going to have 3 over x divided by, and now this is going to be 2x plus 1 over x. Okay? So now we have a fraction divided by a fraction. So we take our top fraction, 3 over x, and multiply it by the bottom fraction turned upside down. So now these x's cancel, and we're left with 3 over 2x plus 1. So this is the most simplified version. So if we were to find just the domain of this one, so remember, when we did the work for the domain, we had this stuff over here. We see x couldn't be 0, and x couldn't be minus 1/2. But if you were only to define the domain of this one, you would only get that x can't be minus 1/2. You wouldn't see that x couldn't be 0 if you just solved this one to find the domain. So that's the reason why we need to find the domain of this version right here, the unsimplified version. So we need to use this to find the domain, not the simplified version. Okay, let's move on to the next question. So the last one from this section, let's say if we have some equation, f of x is equal to the square root of 1 plus x squared over x squared. And let's say this is what we want. So we want this to equal f composed with g of x. Again, what this equals is f of g of x. So we're looking for this f and this g. So one way to do this is let's say that f of x is equal to the square root of 1 plus x over x. And let's say g of x is equal to x squared. So the reason why I'm doing that is, well, we see here that when we're trying to find f of g of x, we're plugging in g inside of f. So it looks like we plugged in the same thing right here and the same thing right here. So one way that allows us to plug things in here and plug things in here is make a function that's what happens. So this function f of x, we still have our square root, our 1 plus, and allows us to plug something in here and plug something in here. See, we can plug something right here, and we can plug something right here. And if we look at this, it looks like the thing that we wanted to plug in was x squared. So the thing that we're plugging into our equation is x squared. So if you see, if we were going to find f composed with g of x, which equals f of g of x, this is going to equal, so f is this function, and we're plugging in g inside of it. So if we're plugging in g inside of f, we're going to have 1 plus g of x all over g of x. And then we said g of x is x squared, so this is going to be 1 plus x squared over x squared. And that's the original one we want. So we see that we can rewrite this function as a composition of f and g. And we decided to define f to be this and g to be this just because it worked out nicely. And again, the reason we knew that it was going to work out was we see this is the function that we want to have written as a composition function. So what we see is that kind of like we plugged in the same thing here and here. We plugged in an x squared here and an x squared here. So a way we can do that is if we define, again, this regular function, this allows us to plug stuff in here and plug stuff in here. And the thing we're going to want to plug in is x squared. So we let g of x be x squared, and then we're going to plug that g of x inside of this f we came up with. So if we do that, we're going to get this. So here's f of x. If we plug g inside of f, well, then a g goes here and a g goes here. Just like if you were going to find, f of 2. This would be the square root of 1 plus 2 over 2. You just replace these x's with 2's. But now we're replacing these x's with g of x's. So the g of x goes here and here. And then we just replace g of x with this definition, and then we get this.